Okay, so we're going to take a look at example 1 from the curve sketching exercises. Okay. All right, where is it? Okay. All right, so example 1 was when you're trying to sketch. Let me just write the problem. Okay, so the problem we're dealing with is that first question on the curve sketching worksheet. Okay, we've already done the first and the second derivative, so that'll help us as we move through the guidelines. And I went ahead and did the factored form, which helps a little bit as we go through this. So let me remind you that the first derivative, we already did this in a different video. So you can try them yourself, try all the first and second derivatives of everything yourself, and then come back, watch that video to check your work. All I'm doing here is not explaining, but just writing down what the final version of the first and the second derivatives were. Okay. Let's see, where did I do it? There it is. Okay. All right, so we're getting ready to sketch this. So we're going to run through, I'll try to do it following the more streamlined guidelines for the most part. I do like to think about the domain. It's a polynomial, so the domain is going to be all reals from negative to positive infinity. All right, that means when I see that, that means no vertical asymptotes. Oh man, this is my new pen. No vertical asymptotes. Okay. Also know with a polynomial, I like to go ahead and just knock out the asymptotes. I also know with a polynomial that that leading term determines the end behavior, and that's where the horizontal asymptotes and slant asymptotes come from. So there's no vertical asymptotes. I know that. Man. Okay. All right. And then horizontal asymptotes. Man, I have a lot of videos to do. I hope this pen doesn't do this the whole time. Okay, then the horizontal asymptotes. Okay, there's none of those because your end behavior comes from x to the fourth, and that would look like this at the ends since they're both even. Okay. All right. So let's go ahead then and do things kind of in the order they're doing it. I'm not going to get any symmetry here since the exponents are both even and odd, so it's not going to have y-axis or origin symmetry. So let me just jump on and think about the first and second derivatives. So f prime of x, okay, would equal 0. Let me just write it. Yeah, I'll do it that way. F prime of x. Don't know why this new pen is messing up. Okay. Would equal 0 if 4 times x minus 1 times x minus 4 winds up equaling 0. And remember, you can kind of do a little shortcut here. So you know that's going to happen when x equals 1 or x equals 4. Okay. X equals positive 1 or x equals positive 4. I don't know what I'm going to do. I need to do 100 videos. Okay. X equals positive 1 or positive 4. All right, and that's when the first derivative would equal 0. Okay, so what that tells me is that on either side of 1 and 4, I'm going to look at whether my function would be positive, negative, or 0, whether my f prime would be positive, negative, or 0. That's going to determine the intervals where it's increasing or decreasing. Okay. Okay, so f prime, if I'm to the left, see, these are the critical points right here. All right, so if I'm at 0 as a test point, what I'm looking at is the factored form here. I would have positive, negative. This would be negative squared, which would be positive. So it'll be negative there. If I'm in between 1 and 4, like at 2, this would be positive, positive. This would be negative, but squared, which would also be positive. And then if I'm over there at 5, I'll have positive, positive, positive. So this would be positive. So these are supposed to be places, 1 and 4 are supposed to be places where I might have a max or a min. What I can tell is that neither of those things will happen at 4. Okay. What f is going to be doing here is it's going to be falling. Between 1 and 4, it's going to be rising, not necessarily nice and constantly straight like that, but just going down from negative infinity to 1, and then in between 1 and 4 going up, and then from 4 on it's going up also. Okay, so that means they're at 4. You don't have a max or a min. It's probably an inflection point, is my guess. But at 1, do you see how it went down and then up? So that means that right there at 1 something, you have an inflection point. I mean, a minimum. So it's a minimum. Okay. All right. And then we can go ahead and figure out what the y coordinate of that is. But what you're plugging into is the f function when you do that. Okay, so I'm going to go find f of 1. I'm looking at the example now. It's a polynomial, so it's going to be 1 to the 4th. You can either do the polynomial or you can do the factored form of the polynomial. Oh, man. To the 3rd plus 48 times 1 squared minus 64 times 1. Okay, so that's 1 minus 12 plus 48 minus, 64. I don't know what happened here. Okay, so that's going to be 48 minus 64 is negative 16. So that's negative 28. That's negative 27. Okay, so this is going to be 1 and then negative 27. And that's going to be the minimum value. Okay. All right, now we're going to look at what causes f double prime to equal 0. And on that one, the second derivative was 12 times x minus 4 times x minus 2. And that would equal 0 when x was 4 or when x was 2. These are the possible inflection points. Okay. And so then I'm going to think about picking a number to the left of 2, like 1, in between 2 and 4, and then to the right. Okay. So these are the possible inflection points right here. So when I plug in a 1, I get a positive. I'm looking at these 3 factors, a positive, negative, negative. So that's positive overall. When I pick 3, it's going to be positive, negative, positive. So it's negative right there. And when I pick 4, it's positive, not 4, 5. It's positive, 1. So 12 and times 1 which is positive, times another positive. So that would be positive. So on this one, do you see how you got the sign change there? That means these right here are inflection points. So you're going to have an inflection point at 2 something and another one at 4 something. 2 inflection points. Ah, okay. All right. Not 40. 4 something. Okay, that's what I'm trying to say. All right, so this is what F double prime is doing sign-wise. And then what F is doing is it's concave up here. Okay, concave up. Here between the two, it's concave down in the middle, and then concave up again. Okay, so it's up, down, up. Only you don't necessarily have the whole U. It's just pieces of that curve. All right, while we're doing this, let's look at what F of 2 would be. And then let's find F of 4 because we're going to need those. Okay, so I'm going to go to the factored form this time. I think I can do it quicker just using the X. Remember, F of X equaled the X equaled X times X minus 4 to the third power. Okay, so if I plug in a 2, I'm going to get 2 times negative 2 to the third. If I plug in 4, I'm going to get 4 times 0 to the third. So it was 4, 0 for one inflection point. The other one is negative 8 times 2, which is negative 16. Okay. Okay. All right, so that gets our little extreme values and inflection points. We already talked earlier about asymptotes and end behavior. We know it's going to open up on both ends, and there are no asymptotes. And then for intercepts, F of X has no, the Y-intercept is going to be at 0, 0. Okay. Right, so for intercepts, I usually find these first, but I'm trying to follow the guidelines. Okay, for the intercepts, for the Y-intercept, you're looking for 0 something. So you're going to just plug in a 0 everywhere there is an X, which means you're going to get a 0. Okay, you can look at that and see. For the X-intercepts, I'm going to take the F function here, which is X times X minus 4 to the third, and I'm going to set it equal to 0, which means this would be 0 or this would be 4. So the X-intercepts are at 0, 0 and at 4, 0. Okay. And then finally we sketch it, and then we can use our graphing calculators or Desmos to see analytically. I mean, to see graphically what it is. We just did it analytically. All right. Okay, so Y-intercept 0. Let me do it in red. Y-intercept is 0, 0. And then over here at 4, 0. Okay. It's the other Y-intercept. All right, and then we had a minimum value at 1, negative 27. So let me just kind of put it down here somewhere. Then we had at 2, negative 16. This was a negative 16 right here. 2, negative 16. Okay, and that right there is 1, negative 27. So 2, negative 16 would maybe be about right there. Okay, is an inflection point. I'll just put IP. So this is an inflection point. This is a min. And then I have another one at 4, 0. That's an inflection point. Okay, and I know the end behavior does this. So that means I'm going to start up here. Start it at the top. Okay. Then I have to go till I get to that minimum. Turn around, curve it around. Then I'm going to be here, and I have to kind of wiggle my way through. No, that's not true. Sorry, I was thinking about something different. So to -16, I have to go from concave up to concave down. Okay. Then right here, I have to go from concave down to concave up. So that's where I'm going to wiggle my way through. And then I wind up with the other end opening up. Okay. So that's what you got. Okay. All right. So I'm going to stop this one.